Now that we've looked at turret terminals, let's move on to several other types of terminals you'll be seeing. The cup-type terminal is a popular one. Actually, it's a hollow cylinder, and the lead is inserted and soldered without any mechanical attachment. The trick is to use just the right amount of solder, not so much that it spills over the top. Here's how it's done. First, the pre-tinned wire is inserted to measure for the correct lead length and insulation gap. Here, the insulation gap is too big, so the wire will be trimmed until the gap is the proper size. The next step is to fill the cup with solder. A short length of solder is twisted together tightly to make what is called a solder preform, and then the preform is inserted into the cup. It's cut off flush with the top of the terminal. The iron is held on the terminal and solder melt observed. The wire is again fully inserted and held in place, and the iron is removed. The important thing is to make sure all the flux has bubbled to the surface, but has not vaporized. Let's watch each of the steps again. The tinned wire is trimmed to provide the correct insulation gap. The solder preform is inserted and trimmed. Then the iron is put on the cup, and after complete solder melt occurs, the wire is inserted all the way and the heat removed. Determining the correct amount of solder to use has to be done experimentally. In this case, too much solder was inserted, and when the wire was put in, it spilled over and down the sides of the cup. In this case, not enough solder was used, and you see practically no solder fillets between the wire and the cup. The preferred joint has these characteristics. Note first that the wire has bottomed in the cup, and there is an insulation gap of the proper dimension. Also, the solder contains no pockets of flux or gas trapped within it, and it has not spilled over and down the sides of the cup. The amount of solder is correct. The fillets are slightly concave, and there's good wetting of the surface, too. Now, here are some bad ones and some good ones. This one has insufficient solder and is unacceptable. There are practically no fillets to be seen. This one is acceptable, but it has only the minimum amount of solder required. And here is the preferred joint, with the slightly concave fillet and good wetting of wire and cup. This one is also acceptable, but has the maximum solder allowed. The fillets are no longer concave. They're beginning to bulge. Finally, this one is unacceptable because of excess solder at the joint and on the terminal body. Soldering cup-type terminals in a connector is often difficult because you have to work in tight places. Often, there's so little space around the cups you can hardly get the iron in without melting or burning the insulation on adjacent wires. In situations like this, a resistance soldering tool can be very useful. It has a pair of electrodes that can grip the cup and send current through it to heat the metal and melt the solder. The current comes from a power source, and the temperature is adjusted to give a dwell time on the joint of 1 to 1.5 seconds. Again, the foot switch is used to control the heat cycle of the work. The big advantage of the resistance tool is that the electrodes can be positioned while they're cold, so there's no danger of heating the wrong area. The cup, with solder already in it, is gripped with firm pressure, and the foot switch depressed for heating. Then the wire is inserted after solder melt is observed. Each time, before the electrodes are removed, the current is turned off to prevent arcing, which may damage the plating on the terminal.